Hello, Miss Carmichael here to talk to you about Lesson 2, so make sure you're on the correct page in your packet. We are going to be continuing talking about rates and unit price, but something new to us might be this word here, complex fraction. So a complex fraction is when you have at least one fraction in the numerator, denominator, or both. So this looks a little crazy. They're kind of scary, but when you have a fraction inside of a fraction, or you could have a fraction on top and a fraction on the bottom. So that's what a complex fraction is. They look kind of scary. All right, so just a heads up, you're going to see those. All right, down below here, we're going to work on writing some ratios. Example 1, there are 45 males and 60 females in a subway car. The subway car is traveling at 2.5 miles in 5 minutes. All right, so lots of information there. They want us to write a ratio of males to females. So we have to write it in that order. So 45 to 60. That's one way to write it, but remember we talked about in class there are 3 ways to write a ratio: as a fraction or with a colon. 60. And sometimes, not always, we can reduce them, and I like to look at the fraction when I reduce. So if I divide by 5, let's see, 9, that's a 9, and 12. So it equals 9/12. This is what we call equivalent ratios because they have the same value. Okay, moving along to letter B. We are going to find the speed of a subway car. And a ratio that's pretty important to know is the ratio of a rate. Okay, if you're finding the rate of something, which is the speed, same thing, it is taking the distance, write this down with me, divided by the time. Distance divided by time will always give you the rate, which is the speed of something. So going back to our story problem at the top, it says the subway car is traveling 2.5 miles in 5 minutes. So that is our distance and our time. So distance is 2.5 and our time is 5 minutes. If we want to find, so this is the rate right here, okay? If I add the miles and the minutes, we have a rate. But what if I wanted to find the unit rate? What would I need to do? Remember, unit rate is when our denominator is 1. Okay, so how do I turn the 5 into a 1? Well, we divide by 5. Divide by 5. So 5 minutes divided by 5 is 1 minute. And then we got to take the 2.5 divided by 5, decimal floating to the surface. 5 goes into 2, and 5 goes into 25 5 times. So it takes us about half a mile every 1 minute. So that is our unit rate because our denominator is 1. Okay, now we're on example 3 where we have a fancy little table. Something that you've probably seen before is like a T-chart or an input-output table that looks like this with the X and the Y, and you can plug in numbers. So this table is actually an input-output table. We just don't have the X and the Y, and it's horizontal instead of the vertical like this one here. All right, but the reason I bring that up is because I want you to think of your top number as your X value and the cost as your Y value, because we're going to be talking about X's and Y's quite a bit. So that's the first thing I want you to add to your table is an X for the amount and Y for the cost. All right, so now we are finding the unit price. So, unit price, you are going to always take your cost, which is your Y value, and you're going to divide it by whatever you're buying. So in this situation, it is square feet. Square feet is going to be our x value. All right, so y divided by x. So I'm going to take every entry from our table, and I'm going to take cost divided by square feet. All right, you ready? So 100 divided by 25. Cost divided by square feet. Our next entry was 400 divided by 100. Cost divided by square feet. Continuing down, cost, 1,600 divided by square feet, 400. Last one, cost was 6,400, and we got 1,600 square feet. So cost divided by square feet every single time. But these crazy big fractions don't really help me compare anything. So what I want to do is reduce them down. Make them something more understandable. So to reduce this fraction, we divide by 25 because we want that denominator of 1. So we want 1 over 4. So for every $4, we got 1 square foot. All right, so that is our unit price right there. All right, this one's easy to simplify. We just cross off those zeros by dividing by 100. Love doing that. And we get $4, gets us 1 square foot. That's cool. All right, we get to divide by 100 again to cross off the zeros, but I also have the 16. So I'm going to divide by 4 and divide by 4. Because that makes 4 divided by 4, 1, to get our 1 as the denominator. And 16 divided by 4 is 4. So $4, again, gets us 1 square foot. All right, one more time. Cross off the double zeros on both of them. And 16 and 64. Dividing by our denominator to get our unit price, 1 square foot. And then 64 divided by 16 is 4. That worked out good. All right, so I have $4 for 1 square foot every single time. So that means that the table shows the cost of different artificial turf. So the artificial turf costs $4 per square foot. Just as a little side note, another way to write square foot is to put foot squared with a little tiny 2. So foot squared that's another way to write it. All right, so they all had the same unit price, so they are proportional to each other. All right, let's turn the page and check out the back. On the back here, we're looking at a complex fraction. We have a fraction within a fraction, and it says that Dave can clean pools at a rate of 5/3 pools per hour. And I went ahead and wrote there's 2 ways that I can decipher this, depending on what I'm trying to figure out. So one way that I rewrote it, as I said that I have 5/3 of a pool is clean in 1 hour. So that is my unit rate. Or I could also break it down and say I can clean 5 pools in 3 hours. Or Dave can, I'm not that fast. So 5 pools in 3 hours, or the 5/3 pools in 1 hour. So let's see what they're wanting us to find. So letter A says discuss what this rate means. So if I use that first ratio here, the 5/3 per 1 hour, it means that in 1 hour, Dave can clean 5/3 of a pool. So it is per hour, so that's our unit rate. All right, question B says, what is the ratio of pools to hours? Well, that's that second ratio that I wrote down, saying that Dave cleans 5 pools in 3 hours. So Dave is super fast. Before we move down to our graph I see here below, I want to go back up to our ratios we wrote at the top. Remember before where I said y is always going to be on top and x is always going to be on bottom? So we have y divided by x. Pools is our y value and hours is our x value. So let's go ahead and take a look at our graph and see if that's still true. Okay? All right, so looking at our graph, we know that this is our x and this is our y, right? And look at our units. Our x unit is time, and over here it says x is hours, good. And numbers of pool is on our y, and that's what I said y was going to be, okay? So I just want you to make that connection that how we set up our ratio is going to affect how we make our graphs in the future, okay? So definitely keep that noted. Okay, so looking at C, it says using this graph, we are going to determine how many pools Dave can clean in, I think yours says 6 hours. If it doesn't say 6 hours, we change it to 6 hours, okay? Because 10 hours doesn't fall on a point very well. Okay, so 6 hours, here's our hours, and here are 6. So we're going to highlight that line there, and we're going to take that line over. And it's 10 pools, okay? So he can clean 10 pools. Let's try it over here. 10 pools in 6 hours, okay? And if you look at those two ratios, they're equivalent, aren't they? Okay, so in 6 hours, he can clean 10 pools. All right, I'm ready for D. Find the point 3, 5. Okay, so go over 3, up 5, there's a point on our line. It's a solution to that graph. What does this point represent in context to our problem? When it says in context to your problem, make sure you use the units given. So in 3 hours, Dave, let's see, 3 hours and go over. Dave can clean 5 pools. Okay, way to go, Dave. Okay, one more thing and you're done with me. Okay, so E says, what ordered pair would be used to represent the unit rate? Why? So I dragged down that rate I was using up above, the 5 pools in 3 hours. But remember, a unit rate has to have a denominator of 1. We don't have a denominator of 1, we have a denominator of 3. So to get the 3 to be a 1, we divide by 3. Divide by 3. So we have 5/3 pool in 1 hour, which is the same thing we had up above as well. Okay, so that is our unit rate. But what would that look like as an ordered pair? Well, remember we have y over x, right? Always y over x. And an ordered pair is x comma y. So now I just have to substitute here. My x value is 1. My y value, 5/3. Okay, so this is our unit rate as an ordered pair. Okay. A unit rate written as an ordered pair will always have an x value of 1. So this is what you need to note for unit rates as an ordered pair. 1 comma r is where you're going to find that on a graph. Thank you for watching this long video. Sorry. Have a good night.